Hello and welcome. In this tutorial, we will learn about data types and variables in Python, so let's get started. In this tutorial, you will learn about different types of data in Python including integers, floats, and strings. Also, you will learn about variables and how to use them. In the previous topic, we performed a basic addition operation which was 4 plus 3 that resulted in 7. The output 7 is an integer number, which is represented as int data type in Python. We also performed another basic division operation which was 2 divided by 4 which resulted in 0.5. The output 0.5 is a decimal number which is represented as float data type in Python. Even if you encounter an integer data type number say 5, this number in Python is not the same as 5.0 as the latter is a float data type although both mathematically are the same. When programming, you have to get used to dealing with different types of data in your code as in many cases you have to keep track of each data type, as in some cases data types cannot be mixed. We will later look at this at some point in this tutorial. Now, Python allows you to check the data type using the type function. For example, to check the type of the integer number 5, you should write type of 5 in the code line and you will get int data type, which is an abbreviation for integer data type in Python. Also, if you check the data type of the division 2 divided by 4, you will get a float result since the output of this division is a decimal number. Now, Python allows you to convert between floats and integers using the float and int functions. To see them in action, suppose you want to convert the float number 5.7 to an integer. The int function will strip away the decimal part of the number and maintain only the integer. So using int of 5.7 will result in 5 only. Similarly, you can convert an integer number to float number using the float function. For example, taking the float of the integer 5 will result in 5.0. Converting an integer number to float will always result in a 0 decimal after conversion. As you saw earlier, we did many operations from addition and multiplication to data type conversion between floats and integers. Also, we used the print function in order to display the output of an instruction or operation. However, when building algorithms and larger code, only displaying the operation's output might not be helpful, because the resulting outputs might be used further down the line in your code. Not doing so will complicate and enlarge your code as you need to pass the same operations again and again. The place where you save a value resulting from an instruction is called a variable. The variable allocates a space in your computer's memory in order to save values that you pass into the same variable. Suppose you want to save the result of the addition operation 4 plus 3 that is value 7 in a variable called x. You can do so by assigning the operation into the variable by the equal symbol. So the equal symbol is said to be assignment operator and not to be confused with equal sign in mathematics. You will realize the difference once we look into the variable assignment shortcuts. Now, this line of code initializes or creates a variable called var1 and assigns the result of the operation, 4.71 plus 3.05 times 2 into it. Therefore, the variable var1 will save the value 15.52 in your computer's memory. However, when assigning an operation to a variable, the output result will not be shown unless you use the print function to display it. To display the output of an operation assigned to variable, you can use the print function whose argument is the variable's value to be printed. So basically, a variable is just a representation by which you access or manipulate the value stored in it. Therefore, you can interact with stored values using the variable itself. For example, you can add a new value, say 4, to a stored value using the name of the variable var1. As mentioned earlier, variables help you save the resulting value from an operation which you can use later on throughout your code. To better explain this matter, suppose you are trying to calculate the calorie content of a certain food. In general, our food contains macronutrients such as proteins, fats, and carbohydrates, including fiber. Now, proteins and carbohydrates have 4 calories per 1 gram of weight, but fats have 9 calories per 1 gram of weight. In general, fiber calculation is deducted from the total amount of carbohydrates. You should ask your dietitian, nutritionist, or doctor on the truth of any info or equations presented regarding food and calorie content for your own safety. This is just an illustration for this tutorial. Having said that, in order to theoretically calculate the calorie content of a certain food, you must know the macronutrients breakdown of the food per 100 grams of weight and total weight of the food in grams. This is the equation which generally can be used to perform the calculation. Now, let us perform a calorie content calculation for a banana with a weight of 152 grams. Bananas in general have 23 grams of carbohydrates per 100 grams of weight, 2.6 grams of fiber per 100 grams of weight, 1.1 grams of proteins per 100 grams of weight, and 0.3 grams of fat per 100 grams of weight. The first technique is to create a single line of code for the equation by writing 4 times 23 minus 2.6 plus 4 times 1.1 plus 9 times 0.3, all times 152 divided by 100. As you can see, it is difficult to keep track of each number in the code line as you will forget the representation of each number and to which category of macronutrients it belongs to. So you have to rewrite the equation once you want to change a macronutrient value or total weight of the food. Therefore, it is better to use the second technique in which you create a variable for each macronutrient and the total weight of the food so that the total calorie equation is written once and you only need to change the values of macronutrients when needed and run the code to calculate the total calorie content. For example, suppose you want to change the value of weight from 152 to 120 grams. Then, you do not need to change all values or even the line of code corresponding to the total calories equation, except for the value of weight variable. The result will be updated once you rerun the code. As you have seen in the output of the previous code, we obtained a total calories of 134.824 for a banana of weight 152 grams. Generally speaking, decimals in calorie content is really insignificant and can be omitted or rounded from the total calories. So we can perform this using 2 techniques. The first technique is to apply the int function in Python to convert the float number of total calories variables to integer. As such, int of total calories. The second technique is to use the round function, which rounds up the decimal if it is greater than 0.5, or rounds down if the decimal is less or equal to 0.5. Alternatively, you can rewrite the code in a different approach by applying the round and int functions directly on the variable itself, and reassigning it to the same variable if you wish in order not to create a new variable name. This is true because a variable is a representation of a value, so you can apply Python functions directly on numerical values or the variables themselves. We updated the total calories variable in the previous section with the integer or rounded version of the same variable, by reassigning the updated value with the same variable name. Now, let us understand this in more details. For example, if you have variable y equals to 10 and you want to update the value of y with addition of 2, then you can write y is equal to y plus 2. The y on the right-hand side of the equation has a value of 10. Now, this line of code initializes a new variable y on the left-hand side of the line of code and assigns the old value of y with the addition of 2, so in this way you can technically update the same variable with a value and the result will be 12. There are other shortcuts when it comes to updating variables in Python. You saw that we can update a variable by equating it with itself and an adjustment value. Doing so, you are required to write the name of the variable twice on the right and left-hand sides of the assignment operator. However, we can update the variable using itself with the following shortcuts. This table shows the syntax for mathematical operation along with an example for each. There are shortcuts for addition, subtraction, multiplication, division, and exponentiation. As you see, the shortcut syntax begins with a mathematical operators followed by equal sign. You can pause the video to read through this table. What we have done so far is that we studied the importance of using a variable, and how to utilize them, convert their data type and update them. Another important aspect is to know how to name them to avoid error messages. Variables should not start with a number or contain white spaces, apostrophes, hyphen, $sign, and commas. Up until this point, we have only dealt with values that are numerical, including both integers and floats. However, those are not the only data types in Python. In this tutorial, we are going to look at strings data type as well. Take a look at the following table. It is a dataset consisting of cereals' food names with the corresponding macronutrients counts. As you can see, there are columns with numerical values such as the fat, protein, fiber, carbs, and sugar columns. However, if you look at the name column, you will find texts representing food name. Any sequence of characters or any textual values are called strings. Strings in Python are of string data type or str. To represent a string value in Python, you need to use either double quotation marks or single quotation marks. For example, you can assign string value to variable as such. Beware that you are not only limited to use letters as strings, but also you can include numbers and spaces as well, such as the following. However, any numerical values in strings are dealt with as characters, not numbers, so you cannot apply mathematical operations on strings including textual numbers. Trying to do so will result in an error message. In some cases, you may want to include apostrophes or quotation marks as part of a string value. However, Python will confuse between your quotation marks included in your string and the quotation marks used to identify a string. For example, suppose you want to have a string with value. Python isn't hard to learn as it is relatively easy. As you can see, there are few apostrophes in the string, so assigning this value to a variable with single quotation marks will throw an error message. Conversely, if you close the string with double quotation marks, Python will understand that the apostrophes in the string are not used to identify the string value but as an integral component of your string characters. Now, what if you want a double quotation marks as part of your string? Well, you will have to do the opposite and use outer single quotation marks to identify a string, but the problem is that a word already has a single quotation mark inside a string. So again, Python will confuse the beginning and the end of the string as shown. To solve this problem and to avoid any error message, you can use \escape character to let Python know that the inner apostrophe in the word is not part of the quotation marks that identify the start and the end of the string. There are 4 important operations used for strings in Python that you will occasionally use, which are string concatenation, repeating characters, string function for data type conversion, and using strings with print function. In string concatenation, 2 or more strings can be joined in Python using the plus operator. Let us take an example. Suppose we have 3 strings, Python, is, and easy. String concatenation will be done by using the addition of those strings. This operator should not be confused with the plus operator used in floats and integers, as the latter will numerically add numbers. As you can see that there are no spaces between words produced with joined strings, so you can add it manually. The second string operation is character repetition using a multiplier. Suppose you have a string x and you want to repeat this character n number of times, then you need to multiply a string by n. This multiplication is not numerical operation, as the multiplication operation here is used for repeating characters. Multiplying a string by 0 or a negative number will not provide any output. The third string operation is that you can convert numerical values to strings and vice versa. In this code sample, we can convert an integer value to a string, then back to float. Initially, we have a variable x with integer value of 3. Here we are printing the value of x and the type of x. You can see that the printed value of x and its type in the output section. Then, we can also convert this integer value to a string using the string function. We are also printing the value of y and the type of y, which result in a string value of 3 with string type. Lastly, we can also convert a string value to a numerical integer or float value using the int function or float function. Here we are considering the float function as an example. You can see that the previous string value of 3 changed to a float type with 0 decimal number. Finally, the last string operation is the one we have already seen many times, which is to incorporate a string inside in a print function, to complement the value to be printed to add more information. In this case, the string inside the print function must be followed by a comma, then the value to be printed.